Hello, I'm Brian Young, and this is 26105 Introduction to the National Electrical Code. I believe this is actually part two because I did a video where I actually looked at the code book and read some of it. I didn't read the whole thing. I know that there are probably chapters that we'll have to revisit when we go through the book. We'll see what they want us to look at. We'll look at 110. We'll probably look at chapter 2, 210, 215, 220, 230. We'll look at those and see what they're about. But let's go ahead and get started. Module 26105, Introduction to the National Electrical Code. Successful completion of this module prepares you to do the following: explain the purpose and history of the National Electrical Code, identify key dates in the history of the National Electrical Code, describe how changes are made to the National Electrical Code, identify the other organizations that produce standards for the manufacture and use of electrical products, navigate the National Electrical Code, explain the layout of the National Electrical Code, use the National Electrical Code to find specific installation requirements. So, performance task, your instructor is going to ask you, under supervision, you should be able to do the following. Use NEC Article 90 to determine the scope of the National Electrical Code. State what is covered and what is not covered by the NEC. Remember, that was 90.3 was the scope. Find the definition of the term feeder in the NEC. Well, we'll look in definitions, Article 100 for the definition of a feeder. Look up the NEC requirements for installing an outlet near a swimming pool. Find the minimum wire bending space required for two 1-aught gauge conductors installed in the junction box or cabinet and entering opposite the terminal. The National Electrical Code, or NEC, sets minimum standards for the safe installation of electrical wiring and equipment. In this module, you will learn the purpose and history of the National Electrical Code. You'll also learn how to navigate the National Electrical Code to find specific installation requirements. The first place you want to look is the table of contents. Get familiar with what kind of articles are in Chapter 2, Chapter 3, Chapter 4, so that you can navigate quickly through the table of contents. A lot of classes will suggest that you use color coding so that you can find things quickly. One point zero, purpose and history of the National Electrical Code. It says there are no performance tasks for this section. NFPA 70, also known as the National Electrical Code, that's a highlight, is published by the National Fire Protection Association. The NEC is one of the most important tools you have as an electrician. This is also a highlight. It describes the minimum requirements for a safe electrical system. The National Electrical Code describes the minimum requirements for a safe electrical system. All electrical work must comply with the currently adopted National Electrical Code and all local ordinances. You'll find the NEC easier to work with once you understand the terminology and how the information is organized. This section introduces you to the National Electrical Code. The first thing I want to tell you about the National Electrical Code, when you signed up for this class, you took an adult basic education equivalent test to see where you are for reading and comprehension. And you were supposed to have a 9th grade reading level and comprehension level. So a grade of 9.0 on that test qualifies you to take this class. If you aced that test and you got everything right, you would have a 12.9. I'm not sure if it goes to 12.8 or 12.9. I think it goes to 12.9. 12.9 is 12th grade, 9th month, and that's as high as that test tests you. So if you got everything right, they said you are a 12.9, meaning 12th year, ninth month. So you have as high of a reading or comprehension level as they can test for. The National Electrical Code is written on a Lexile score of 15. That's 3 years of college. You're not going to understand the code book. Don't get frustrated. You pick up the book, you read something, and you don't understand it. Read it again. Go to class and ask your instructor. I don't understand what this means. Look up in the Article 100 definitions. Try to find out what the meaning of the words you don't understand. What do they actually mean? And most of it, you're not going to understand until somebody reads it to you and says, this is what they're saying. And once they tell you this is what they're saying, things will start becoming clear to you. You'll start understanding. Like I say, the National Electrical Code is a legal document. Municipalities will adopt the National Electrical Code as their law. And so it's written like a law book. It is very hard to just pick up and read and understand it the first time. Don't be frustrated. Attempt it a few times. If you don't get it, just move on. Go on with your studies, and then when you get back with your instructor, you can ask the questions you're unsure about. Okay? But again, the more you read it, the more you'll understand it. There are some sections in the code book that I had to read 10 or 12 times as a student before I thoroughly understood what they were talking about. So don't allow it to defeat you. Don't read it twice and say, well, I'll never get this. I must be stupid. No, you're not. That book is very difficult to read and interpret the first couple of times you read it. The more you read it, you'll understand a little bit more and a little bit more and a little bit more until it becomes second nature. And even now, there are things that I will read in the code book that I'll have to go look up to try to find out exactly what it is that they're saying. When they say that the wires must be run perpendicular to the long dimension in a chase, you're not sure exactly what they mean. But when you get to that section and you ask questions, somebody will tell you what they mean is you run them horizontally between the studs. It's perpendicular to the long dimension of the air gap between those two studs. And that is in the code under other spaces. You have air handling spaces and you have other spaces, and you're allowed to run it through walls as long as you're running perpendicular to the long dimension of the space. And it still sounds screwy to me. Why didn't they just say short distance? Run it between the studs. But it will come to you. Don't let it defeat you. Okay? That's my advice. 1.1.0, Introducing the National Electrical Code. The NEC may be the most widely used and generally accepted code in the world. It's available in many languages. Electricians in the United States use it as an installation, safety, and reference guide. Meeting the National Electrical Code requirements increases the safety of your electrical installation, and in most municipalities it is the law. You have to. NEC Section 90.2a states that the primary purpose of the code is the practical safeguarding of persons and property from hazards arising from the use of electricity. We had to memorize that as first-year apprentices. We had to memorize that. This means its purpose is to keep people and property safe from dangers of electricity. One of your first requirements in becoming a trained electrician is to have a thorough knowledge of the National Electrical Code. Most of the time, you should use the latest edition of the NEC as your on-the-job reference. The only exception is if your local law specify a different edition. In that case, your employer will tell you which edition to use. Keep in mind that the National Electrical Code specifies only minimum requirements. Always check the local or job requirements, which may be more stringent. One example of that is the National Electrical Code says we can use conduit as a grounding conductor. Here in Florida, most municipalities that are coastal, because of salt air, they say no, you have to run an additional internal grounding equipment ground, either insulated or bare in the conduit, but you have to have a separate equipment ground other than the conduit because of corrosion. That conduit will rust. So that goes above and beyond the National Electrical Code. 1.1.1 Evolution of the NEC. The National Electrical Code has a rich history from 1881 to today, as shown in Figure 1. So 1881, the National Association of Fire Engineers decides to draft the first National Electrical Code. The National Board of Fire Underwriters publishes the first nationally recommended electrical code in 1895. 1896, members of the National Electrical Light Association conference unanimously approve a set of requirements to meet the needs of the insurance industry, electrical utilities, manufacturing, and industry. 1897, the National Conference on Standard Electrical Rules publishes the first edition of the National Electrical Code, and the NEC becomes the very first cooperatively produced national code. 1911, the National Fire Protection Association takes over the administration and control of the National Electrical Code. However, the NBFU continues to publish the NEC until 1962. So now it's the National Fire Protection Association that is responsible for and publishes the National Electrical Code, NFPA 70. The NEC is rearranged and rewritten in 1923. Editors make extensive formatting changes to the NEC. They're trying to format it as a legal document with chapters, articles, parts, sub-articles, subsets, and all of that is spelled out. The National Electrical Code is reorganized into its present structure, consisting of correlating committee and code-making panels, 1949. The NEC adopts a new numbering system, 1959. The NFPA takes over publishing the NEC from the NBFU. And today, the NEC is one of the most widely used and generally accepted codes in the world. I know that there's been a lot of changes in my lifetime. One of the changes, we used to use a dot. We'd say 220.6, 220. Well, people were mistaking that dot. I'm sorry, excuse me. I said that wrong. It was a dash, 220 dash. And now they use a dot. But it used to be, 310-15, 310-16. Now it's a dot. That dot is not a decimal point. So 310.12. I'm trying to think of an example. Like 310.12 would come after 310.5 if there were a 310.5. 310.5 is lower than 310.12 because 5 is less than 12. It's not 310.55152. It's not a decimal point. So I've had students looking for something in the code book and they couldn't find it because they were looking in the wrong place, just because they were using that as a decimal point. Like 220.66 comes before 220.122. And you'd think, well, 220.1 is less than 220.6. It's not a decimal point. 1.1.2, what the NEC Correlating Committee and Code Making Panels do. Two important groups that work to produce the National Electrical Code are the Correlating Committee and the Code Making Panels. The purpose of the Correlating Committee is to ensure There are no conflicts between requirements. Correlation has been achieved. In other words, if a requirement is changed in one place, the same requirement is changed in every other place it appears. NFPA regulations, governing committees, projects have been followed. A practical schedule of revisions and publication is established and maintained. It's every 3 years. Members of the correlating committee and code-making panels supervise and revise articles based on their areas of expertise. Members of the code-making panels come from the following special interest groups. This is a highlight: trade associations, electrical inspectors, insurance organizations. So someone from National Electrical Manufacturers Association will be present in most of the cable code-making panels. Someone from the International Brotherhood of Electrical Workers, the IBEW, will be there. Someone from NECA, the National Electrical Contractors Association, will be there. These are people who have an interest in the code and want to make sure that it is the best document that it can be. And even with that, every 3 years it gets edited. Every 3 years it changes. So trade associations, electrical inspectors, insurance organizations, these are some of the people who are interested in being on the code-making panels. Each panel is set up so that not more than 1/3 of its members are from a single interest group. Code-making panels create or revise requirements for the National Electrical Code through researching, debating, analyzing, weighing, and reviewing new input. The correlating committee reviews the proposed changes. This process ensures that the changes are consistent between articles of the National Electrical Code as well as other NFPA coded codes and standards. So they all follow the same format where they'll use chapters and parts and articles, and those articles will be broken into subdivisions. What NFPA does. NFPA publishes the National Electrical Code. National Fire Protection Association performs many duties, but its primary mission is to provide information and training to minimize the risk associated with fire, electrical, and other hazards. In addition to publishing the National Electrical Code, the duties of the National Fire Protection Association include the following: developing, publishing, and distributing standards that are intended to minimize the possibility and effects of fire and explosion, conducting fire safety education programs for the general public, providing information on fire protection, prevention, and suppression, compiling annual statistics on causes and occupancies of fires, large loss fires over $1 million, fire deaths, and firefighter casualties, providing field services by specialists on electricity, flammable liquids and gases, and marine fire concerns, conducting research projects that apply statistical methods as well as operations research to develop computer models and data management systems. 1.2.0 Revision Process. The NEC is updated every 3 years. Ooh, that actually should be a highlight. It's updated every 3 years. You do not have to be on a formal NFPA or NEC committee to take part in the NEC development and change process. Anyone can do it. You can submit a proposal by using the NFPA website at www.nfpa.org. Technical committees with expertise in the related areas review the proposal. Each proposal follows the 4 steps of the NFPA standards development process. So they get public input, there's a public comment stage, then the NFPA technical meeting, and then the council appeals and issuance of standards. So the public input stage is when the NFPA accepts input through its website. Public comment stage is when comments related to the first draft are submitted during this step. These comments are reviewed by the technical committee during the second draft meeting. After this period, amending motions to any previously submitted comments can be made using the notice of intent to make a motion. NFPA technical meeting occurs after the public input and public comment stages. Additional discussions about the standard is held at the NFPA technical meeting, which occurs at the annual NFPA conference and expo. Council appeals and issuance standard occurs when the council convenes. It considers any appeal and determines whether to issue the standard. If the decision is made to proceed, the standard takes effect 20 days after issuance. So it's a way that the public can make suggestions, and then they publish those suggestions, and you can get a free copy of all of the suggestions that they received. And then you can look at them and you can comment publicly. You can go on their website, you can make a comment about somebody else's suggestion. And you need to keep it professional, of course. Don't call anyone names. You just say, this is why I support this proposed amendment. This is why I do not support this amendment. And they'll take everyone's opinion into consideration. Then they, as professionals, will debate it amongst themselves, and they'll come to a final determination as to if they want to include that recommendation in the next publication of the National Electrical Code. And then they will publish that in their results finding. And if you really feel strongly about something, you can file an appeal, and then the appeal will be the final decision, and there's no more debating it after that. 1.3.0 Other organizations and laboratories. Nationally recognized testing laboratories. Nationally recognized testing laboratories, NRTLs. That's Underwriters Laboratory. Product safety certification laboratories that are responsible for testing and certifying electrical equipment are product safety certification laboratories. These laboratories test new products to make sure they're built to meet the applicable standards of electrical and fire safety. If a product passes the tests, it can display the certification mark. Nationally recognized testing laboratories establish and operate product safety certification programs. The programs ensure items produced under the service meet standards that protect against reasonably foreseeable risks. Nationally recognized testing laboratories run a worldwide network of field representatives. The representatives make unannounced visits to factories to check products that have been certified. OSHA publishes a list of nationally recognized testing laboratories. The one you're probably the most familiar with is Underwriters Solutions, formerly known as Underwriters Laboratories. Some of the others include the following: the Canadian Standards Association, CSA, also known as CSA International, Eurofin's Met Labs, formerly Met Laboratories, Intertech Testing Services, formerly ETL. So the history of Underwriters Laboratories. The Chicago World's Fair opened in 1893. Thanks to Edison's introduction of the electric light bulb, it included a light display named the Palace of Electricity. But there was trouble. Wires sputtered and crackled. The Palace of Electricity caught fire. The fair's insurance company brought in William Henry Merrill, a troubleshooting engineer. Merrill found fault and brittle insulation, bare wires, worn out and deteriorating wire, and overloaded circuits. Merrill called for standards in the electrical industry. He set up a testing laboratory above a Chicago firehouse where an independent testing organization known as the Underwriters Electrical Bureau was born. The organization then became the Underwriters Laboratories, an internationally recognized authority on product safety testing, safety certification, and standards development. In 2022, UL rebranded and is now known as UL Solutions. 1.3.2 National Electrical Manufacturers Association. The National Electrical Manufacturers Association was founded in 1926 It's made up of companies that manufacture equipment for generation, transmission, distribution, control, and utilization of electric power. The objectives of NEMA include the following: maintain and improve the quality and reliability of products, ensure safety standards in the manufacture and use of products, develop product standards in areas such as naming, rating, performance, testing, and dimensions, help to develop the National Electrical Code, and promote its use by state and local authorities. So you go to the store and you buy a toaster and you bring it home and it's got a plug on it. It's got a male plug. And that plug fits in the receptacle in your kitchen. The reason for that is because of National Electrical Manufacturers Association, who have standardized what the shape of a 15 or 20 amp receptacle, 120 volt, what it looks like, the dimension between the blades, how long the blades are, how wide they are, and after they came up with an equipment grounding conductor, they came up with the placement of that equipment ground. That way you can buy that toaster, bring it home and plug it in, and not fear when you're buying it, I hope that this works with my receptacles because my receptacles look different than anyone else's. Nope. If they're made in the United States and they're used here in the United States, they're all specific to the National Electrical Manufacturers Association's standards and rules that they've put forth. They've standardized it across the board so that no matter who manufactures that receptacle, it's going to accept those male plugs from any manufacturer who manufactures the male plugs. They all go together. They all have to comply with that standard. 1.3.3 Standards and Globalization. The electronics manufacturing process involves the manufacture, distribution, and assembly of parts from many countries. This means there's a need for international standards. Such standards provide benefits to all countries, including protecting consumer safety, creating a framework for sharing knowledge, promoting trade, and increasing economic progress. Two organizations that play critical roles in worldwide electrical standards are the International Electrotechnical Commission, IEC, which prepares and publishes international standards for electrical and electronic technologies, and the Institute for Electrical and Electronic Engineers, the IEEE, which is a professional organization that develops international standards for electronics, telecommunications, information technology, and power generation products and services. 1.0.0 Section Review. Today, the National Electrical Code is administered by the National Fire Protection Association. You do not have to be on a formal NFPA or NEC committee to take part in the NEC development and change process. True. Two organizations working toward globalization of electronic standards are the IEC and the IEEE. Very good. We'll go on to the next section.